Hello everybody, this is Mr. McAllen again, and I want to use this opportunity to talk to you guys about how to use a given graph of a function to estimate where the derivative are zero, derivative values are zero, positive, and negative, and then we'll contrast that with looking at the same graph to figure out where the second derivative values would be zero, positive, and negative. This video is not intended to be more than 10 minutes, so let's get started. Alright, so when we look at the function, I just drew a random sketch on a domain from 0 to 8, and we want to just work with the derivative, finding where it's 0, positive, and negative. And this is something that we should all, at this point in our calculus curriculum, we should know, have a generally good idea of how to do this. Wherever the function is, wherever f of x is decreasing, the derivative must be negative. Wherever the function is increasing, the derivative must be positive, and wherever the derivative is, where the function is stationary, that's where f prime of x is equal to 0. Okay, so here we go. You could argue that right here the derivative is stationary at the left endpoint, and on this region here the derivative is negative because the function is decreasing, and then it's still negative. And then here the derivative is 0, and the derivative, you just have to draw little tangent lines to tell you, based on the slope of those tangent lines, that tells you what the derivative is. So here you have another 0 value. So instead of trying to think of all the values on the graph, we use a number line concept. So here I'm just going to draw, using blue, I'm going to have the derivative number line, and what I first look at is where is my function stationary. So right here at 0, you could say that the derivative has a 0 slope, and then if we look at 4, you could say that my derivative is equal to 0 there, and at 7 my derivative is equal to is equal to 0 there. So now we are going to look at, since the function is decreasing on this interval from 0 to 4, we would put a negative value for the derivative. On the interval from 4 to 7, we would say it's positive because the function is increasing. And then in the last interval from 7 to 8, it's decreasing again. So that's how we would identify the first derivative values as far as being negative, positive, or 0. The second item is concavity, or what the second derivative value would be, and I'm going to use a green color to do that. So my number line will be green for the second derivative, and what I'm going to do is I'm going to look at where the function is frowning. So in this region here, I'm going to draw it in green. There's definitely some frowning going on, and that is downward concavity. In this region here, the function is smiling, and it just so happens that I have the connection between frowning and smiling on the x-axis. That doesn't always happen. So this is a happy function. So we have smiling going on there. That's concave up, and then for the rest of the domain, the function is frowning, and that's concave down. We represent concave up, concave down with as far as on the number line, as regions where the derivative is positive. The second derivative is positive and negative, respectively. So we have concave down behavior from 0 to 2, and then at 2 it switches to concave up behavior, which would be the second derivative being positive, and then at 5 the concavity switches again to downward concavity, and that happens for the rest of the domain. Well, there you have it. That indicates that because we have a change in concavity from at 2, this would be on the function graph called a point of inflection. And because we have another point where the concavity changes at x equals 5, we have another point of inflection. And in terms of local mins and local maxes, wherever you have a derivative changing from negative to positive, that means at x equals 4, you have let me change the color to blue again. We have here a local min, and here you would have at 7, because we change from positive to negative, we have what's called a local max on our function. Hopefully this video helps point a few things out. The next video I put up will be something to deal with the second derivative test for finding mins and maxes. So tune in for that one, and if you like this video, please subscribe and like it. Look forward to hearing your comments. Take care. And if you have any comments or any videos that you would like to have explanation for, in the comment section, just post what you would like to see. Have a good night.